Loads. It's loads.
Yeah, but what do you think came next? So we have energy, matter. First starts with matter. Let's say quarks and atoms, and then
probably. Well, if there was only energy and mass, there must have been elements sort of forming out of mass.
Good, right? So so it has to be one element first.
Yes.
So elements are like the different types of atoms that exist in our universe, and it's like more than 100 now that can possibly exist.
Yeah.
Number one is
begins with a H.
Is it high? No, I don't know.
Yeah. Say with confidence.
Yeah.
Is it? I know the word. I know the word. Hi, my name's Raafae. Hydrogen.
There you go.
Good job.
Hydrogen. Exactly.
Yes.
Right. So because that's the simplest atom you can have.
Yeah.
So we have only hydrogen at a start.
It has like one electron.
So one electron, one proton.
Yeah.
Right, now you have all this bunch of hydrogen now, but it's dispersed across how much ever of the universe is there at this moment in time.
Yeah.
What happens next?
I think other elements start forming that are a bit more advanced, have more...
heavier, But for that, you can take it away.
Sorry, I was thinking, well, next got to be the dinosaurs.
So you got hydrogen
and then dinosaurs.
But how they come together? So you got one hydrogen atom here, one hydrogen atom somewhere.
The electrons change.
Why do they come together? Do you know why they come together?
All right, I thought you could run with this.
I was in a different space. What makes two things come together?
Gravity.
Oh, very good.
Yeah,
you can
good
a high five for that.
Okay.
So gravity starts pulling all this stuff that's everywhere
together
into lots and lots of different things.
So they trade like electrons, so they become different matter.
Not yet.
But we'll get there. They have to pull together first.
Yeah.
So things, all the stuff, so all the stuff that exists in the universe in various forms, back to the energy conversation, is created.
Yes.
For want of a better way of putting it, or is suddenly apparent.
Yeah.
And then that stuff starts clumping into lumps and clouds, big clouds, of various bits and bobs.
Yeah.
And then once you've got these big clouds of various bits and bobs, that's when things start to change and things start to.
And that's like nowadays space clouds, like we.
Yeah. So you still have interstellar clouds, right? Mostly at that point there would be mostly hydrogen. I mean, almost, actually not mostly, only hydrogen. Sorry, and maybe some other subatomic particles. Gravity keeps pulling them together more, and they start to form into like this sphere. Now, if there's enough gravity, what's going to happen is it's just going to keep pulling things together.
Yeah.
Still all hydrogen.
Okay.
Right.
Yes.
And it's going to squeeze it. All that gravity is going to act and squeeze these atoms closer and closer together.
Yeah.
And then we have a process called fusion.
Fusion.
Where these atoms are so close together now they fuse and they form a heavier atom.
Okay.
So the first one that would form is after hydrogen.
After hydrogen.
Number two? No? So it's helium.
Yes, I know.
Okay. Yeah. Anyway.
I have like this periodic table stuck to my head.
So it's helium. And the reason why it's called helium is because of Helios, right?
Yeah.
Helios, sun, right?
Yeah.
So forms into helium.
Yeah.
And that process, that nuclear fusion, releases so much energy, and then you have your first stars start to shine.
Okay.
Pretty cool.
So actually, we just linked to my next question, which was about the stars. How the elements started growing more complex, and how the white stars, how they grow big and they become white, and then they shrink and then they go brown.
Yeah, so there's like this whole life cycle of stars.
Dead Star.
Yeah. Like the Death Star.
My favourite star.
Yeah, so first you form helium, now stars are starting to shine for the first time. then after that, but then you take helium and it's still in there, right? In the center of a star, and maybe there's enough gravity for another hydrogen atom to join onto it. And now you're beginning to form the slightly heavier elements, but not in slightly, it's still number 3 and 4 on the list, right? Lithium. And then you slowly, so by this process, you get heavier elements. Now, I think in a star the size of our sun, you can't really get much heavier than, I think, carbon or nitrogen. Okay, but what happens is now stars aren't eternal. Like there is a day that they stop burning, because at a point what happens is they just run out of fuel. There's just not enough hydrogen to keep this nuclear fusion reaction going. So they run out of fuel, and as they run out of fuel, they start to expand first. And they go into, like, it depends what it started off as, but like ours will go into like a red giant, right? And I'm not too great with the whole life cycle, but then sometimes at a certain size of star actually would explode in a nova or supernova. And all of this stuff that was cooked up inside that star, these heavy atoms, right? Like, let's say carbon and nitrogen and even oxygen explodes across the universe.
Spewed.
Yeah.
Nice.
Now, but so there are generations. So our star, I think, is like a second generation star. So they were the older stars first. And sometimes in those explosions as well, new elements can be formed in those explosions because of just the crazy force. So even the heavy ones like iron and things like that, like the metals, get formed in like exploding stars of like supernova and above, then hypernova. And then this is spewed across the universe for this whole process to happen again, and another star to form, right? So I think our sun is like second generation, maybe. I think I have only like one documentary I've probably watched.
I know where it is.
So then the next star forms. Now around this though, now you have all of these other, so before we just had hydrogen floating around. Now you have different amounts of carbon and nitrogen and oxygen and some of the heavier stuff as well, like iron and copper floating around for gravity to do its business again over billions of years and coalesce and join them up into another ball. Sometimes if there's enough hydrogen and stuff, it's a star. And if there isn't, then you may even get planets. Or it'll start smaller, let's say an asteroid. Or something like the size of the moon. And then now you have planets. And so like your rocky planets, right? Terrestrial planets.
Very good.
I didn't say rocky.
That one. I like rocky.
Okay, but then if there isn't enough hydrogen and all these other gases, right? If there's just not enough, instead of becoming a star, what it becomes is a gas giant. Like Jupiter. Which they thought was actually probably like the biggest a planet can get before it becomes a star. But then they found one that's like
much bigger,
like 3 something times bigger than Jupiter. Just like in the last few weeks.
Yeah, it's totally changed. Assumptions.
So okay. So wow,
it's not in our solar system.
So now moving closer to our planet.
I love it.
You're leading this.
I love this. Like, it's probably chronological.
When are we going to get to cats?
We're dinosaurs right now.
Dinosaurs. We're nowhere near the dinosaurs.
So our sun, just to give you an idea of where we are. So we started 13.8 billion years. The first stars, I don't know, dude. Like, I don't know dates offhand. I wasn't there, obviously. Although it was.
Sort of.
So basically, an offshoot of this, by the way, which is an amazing fact to know, that so the atom, so your body, right, is mainly carbon, nitrogen, oxygen with some iron thrown in there, hydrogen as well, some iron thrown in there, and calcium, and all of those atoms were cooked up inside a star billions of years ago. And then that star vomited it all out as it exploded. So you are actually made, if I want to say poetically, star stuff.
Star stuff.
Be honest, that's
Sorry, is that
Carl
poetic?
Sagan.
Star stuff. Stardust.
Stardust. Yeah, that's what I was going. The Carl Sagan. Yeah, the Carl Sagan quote came in my head. So stardust. That's poetic. Star stuff, which is what Carl Sagan said. Or less poetic, way less, star vomit.
Wow.
Yeah, shrapnel.
Yeah.
All right. So that's what you're made out of now. So you have a special place in the universe.
Yeah.
You are very much a part of this universe, right?
Yeah.
And but not to make it less special, so is everything here. So the wood, right, and this table, again, carbon, hydrogen, oxygen was cooked up billions of years ago in a star.
Wow,
right.
So everything just came from that tiny dot. Then there was stars from hydrogen.
Lots of stuff happened. Yeah.
Lots of stuff happened. Yeah. I love that. Lots of stuff happened.
Basically. So then 13.8 billion years, Big Bang, about, I'm guessing 10 to 12 billion years ago, first stars. Our star, I think, is about 5 billion years old. The Earth and the other planets are around 4.5 billion years.
Okay, so the sun was around
just a little bit
half a billion years.
Because you needed the sun's gravity to pull
all the
other dust in.
So without gravity, the universe would just be a cloud of hydrogen floating off apart, away from each other.
Expansive, like waste.
Yeah.
Okay. So it orders the universe.
Thanks, gravity.
So this is way before any sort of civilization. Way before. So when was,
as far as we know, could be on another planet somewhere.
Okay. Yeah, we'll get to that.